Hello guys, so we are going to continue the discussion with respect to linear transformations, and in this video we are going to see some of the visualization of linear transformation. Okay, now you know that what does transformation basically do? It takes up a vector and it can be of any dimension and converts into a different vector itself. Specifically with respect to linear, it satisfies two important conditions. One is homogeneity and one is additivity. Okay, so to make sure that I probably provide you a easy example so that you'll also be able to understand and visualize it easily. Let's take a transformation technique in this. This is basically a linear transformation, which is probably taking any values that belong to real values itself, real number, and we will try to convert this into another real number. Understand over here is that this is completely one dimension. Okay. So when I say one dimension, so if I just take as an example, let's consider this as an axis. So here I have values like 1, 2, 3, 4. And here I have values like -1, -2, -3, -4. Now, during this particular scenario, if I probably consider this, let's say the kind of transformation if I specifically apply, okay, over here is nothing but t of x. Let's say that I'm going to apply t of x, and here I'm just going to say that, hey, we are going to multiply x with 2, right? So once I probably multiply x with 2, if I probably go ahead and see what will be the new axis that will probably get created for any one dimension values, right? And this is one dimension, right? All the data points. So let's consider this is 0. Now, for every number over here, which this is my x-axis, for every number over here, if I apply this transformation, then what is 0 going to get converted to? 0, right? Because 2 multiplied by 0 will be 0. So here I have 0. 1 will be specifically converted over here, right? Over here, 1 will be converted into what? 2, right? So when 1 is basically getting converted into 2, now this indicates that since we are multiplying this by 2, right? So here you'll be able to, this same one, when I probably try to display it over here, right? It'll just get changed to something in this way. In this way, the transformation will get completely changed. This one will basically become 2 over here, right? This 2 will be becoming 4 over here. This 3 will become 6 over here. This 4 will become 8 over here. Similarly, -2, -4, -6, and -8. Right? So this is a perfect example of this kind of transformation that is specifically happening. And if you also go ahead and check this and whether it satisfies linear transformation or not, the answer is yes. Okay. You may be thinking, Krish, how you are able to say it? You know, how you are just able to say it because you even did not try it. Guys, just look at this diagram and look at this diagram, right? Right now, all our data points over here, the scale has been changed, but it is in the same linear line. Okay. Similarly, let's say that if I have another transformation which looks like this, tx is equal to 1 by 2x. Now in this scenario, what will happen? My previous transformation that I had 0, this 1 will basically become 1 by 2 over here. 1 by 2, right? Then this 2 will become 1. Then this 3 will become 3 by 2. Then 4 will become basically 3 by 2 is nothing but 2, right? So in short, the scale is for every unit, it is becoming half, right? So here I'll be having 1 by 2, -2 by 2, that is -1, -3 by 2, and finally you have 4 by 2, right? 2. So this is how the new transformation basically looks like, right? So this is just to make you understand how things work. And you can also go ahead and try out with different operations. Let's say if I go ahead and take my another transformation where I'm multiplying by -3. Then what will happen? The scale will just move. Scale will move towards this side, you know, on the left hand side, but it is still linear, right? So understand one thing, the word transformation means the same thing as the word function, right? Right now we are just going to apply some kind of function. Let's say one of the function over here can be, I can also write this transformation as f of x is equal to 2x, right? This one, I can also write this one, right? So guys, one very important thing that I really want to cover with respect to this transformations that we have done, right? One of the very important property over here is that all this transformation, right, that we have done over here, origin is fixed, right? And the scale may be changing, right? And that is the reason we say this as linear transformation. One of the very important property of the linear transformation will be that the origin must remain fixed. So here, let me go ahead and write. There's some very important property that you really need to look at, right? If you really want to identify whether it is a linear transformation, whether any transformation is linear transformation or not. So here there are two things. One is origin must be fixed, and the second one, all lines must remain lines, right? And right now, if I just consider this as an example, so this line is still a line, right, with respect to one dimension. But again, a better way to basically understand is to probably see a 2D matrix, okay? Then only you'll be able to understand 2 dimension, okay? So for this, I was looking for various visualization diagram to show it to you. But one of the channel, amazing channel it is, 3 blue, brown, brown clips, right? So here I will just show you an example with respect to 2-dimensional linear transformation and non-linear transformation also, okay? Please observe very carefully, okay? So please observe. Again, the credit goes to this particular channel. For that, I will be giving you the link in the description of this particular video, right? So here you can see. So when the transformation is done, right, if I probably consider one of the point as origin, that is going to remain as origin, right? The scale can be changing with respect to the transformation. Again, if I repeat this, see, let's consider this as my origin. So this point is still my origin, right? See, this point is still my origin, right? Scale may change, but the origin will remain intact, right? So this is one example with respect to the 2-dimensional linear transformation. Let's take this as an example, non-linear dimension, right? Now in this case, let's say this is 0. Now here you can see that my origin has completely changed. And now I'm not even having a straight line. It is completely different lines itself, right? So here I have a straight line, but the value changes. As I said, there are 2 important conditions. One is all line must remain lines, right? In the other scenario, there were no lines itself, right? If I just go ahead and repeat this, here you can see this has become a curvy line, right? And if you go ahead, you may be thinking, Krish, this may be also a straight line. Understand over here, guys. First of all, the origin has got shifted, right? One of the condition is becoming false over here, right? So guys, let's take one more example over here with respect to 90-degree rotation. So this is also a kind of linear transformation. Let's consider this. So here I have the specific vectors, and this is just a unit vector that we are able to see, right? Now see this transformation. So this is just 90-degree rotation, okay? Again, let me repeat it. See this. This is just like 90-degree rotation. We have rotated this entire thing. The origin remained as an origin, and all the straight lines remain at this as a straight line itself. So this is one amazing example of 90-degree specific rotation. And in case of 2-dimensional linear transformation, here you can see origin will remain origin itself, and the straight line will remain straight lines, right? If either one of the condition is gone, then it will be not a linear transformation. So this was about the linear transformation visualization. Again, I will be giving you this specific link. Please make sure that you watch that link so that you will be able to see this, okay? So yes, this was it. I will see you all in the next video. Thank you.